Well, MOOG is a diversified industrial manufacturer. I happen to be with the Space and Defense Group. We have a variety of different divisions or business units. We have a mechanisms group, propulsion group, a tactical missile group, surveillance group, and a vibration control group. Our headquarters are in East Aurora, New York, but my particular group actually happens to be resident here in Silicon Valley in Mountain View.
So what sort of projects is it that you guys are doing right now, especially in the propulsion and satellite areas that people need to know about?
Well, one of the areas that we spend quite a bit of time on is developing secondary payload adapters, and what that allows smaller satellite manufacturers to do is if a launch vehicle manufacturer such as ULA or SpaceX has additional launch capacity, they may have a primary payload that doesn't use the full capacity of the launch vehicle. With our ESPA ring technology, that can be placed between the primary payload and the launch vehicle, and that allows up to 6 smaller secondary payloads to be dispensed as a part of that particular mission. So the primary launch vehicle provider or the payload customer benefits in that they may be able to recoup some of that launch capacity and turn that into an additional revenue stream. And then from the secondary payload satellite manufacturer's perspective, that allows them to gain access to space that they might not normally be able to achieve because of the limited number of launch vehicles that are typically available.
Now, are you guys doing this secondary payload on an independent basis, or are you also part of NASA's rideshare program?
Well, the ESPA ring was actually developed under a small business innovative research contract. Prior to 2008, MOOG CSA was actually a small business. Then in 2008, we were acquired by MOOG Corporation. But the original development for the ESPA ring was actually being funded by the Air Force Research Laboratory out of Kirtland Air Force Base in New Mexico. So the original missions were originally targeted for Air Force payloads, but subsequently after that mission was flown, the Northrop Grumman Corporation used the ESPA ring as the basis for the structural hub for the LCROSS mission that ultimately went to the moon in looking for water on the lunar surface.
So what sort of programs or developments would be able to fly on this rideshare program in the future? I mean, is it standardized for CubeSats? Do you have to have...
Well, we actually have the capability to accommodate both CubeSats and what we would call ESPA class secondary payloads, which would be typically on the order of 180 kilograms or below. The way the ring is structured is that you can actually accommodate both on the same flight. So you may have say an ESPA class payload that might be on the order of 100, 150 kilograms. Those can be distributed around the outer perimeter of the ring, and then once those have been launched, we can actually dispense a number of smaller secondary CubeSats once those secondary payloads have been shot away from the ring structure itself. So we can accomplish both at the same time on the same mission.
Now tell me about some of the software developments that you guys have done to complement this technology.
Well, software are divisions that handle flight control computers. They make a variety of different aviation products. I have a separate aircraft group that does flight control computers for things like the 777 and that Boeing series right there. But we do a variety of different software products, primarily in the form of firmware for controlling things such as antenna pointing mechanisms, solar array drives, and then right now we're also working on a sequencer which will be used to control the dispensing of the secondary payloads once the missions have been manifested for the ESPA ring.